So now that we know tangent, we can learn cosine and sine ratios. They use the same concept with the opposite, the hypotenuse, the adjacent, having to figure out which angle you're in relation to. They just have different ratios. So make sure you write down your essential question, etc. Okay, again, you don't need to write down this part if you don't want to, but you need to write down this and the picture. Okay? So you'll notice that, so maybe pause and do that before I talk, or wait till after I talk, write it as I talk, whatever, as long as you get it written in your notes and you understand what it says. So you'll notice we have new, so tangent was opposite over adjacent, right? Well, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So now we get to use that hypotenuse in our ratios. Okay, and there's a little mnemonic kind of. So if you use all of the initials, right, that would be so, ka, toa. Okay. If you go far enough in math, you will do even more with this. If you go all the way to like really, really high math in college, they will tell you this is like too basic, but it's just perfect for us. Okay. This is what will be written on the board. You need to know that means sine, opposite, hypotenuse, etc. Okay. You need to know what it stands for, but this will be written on the board for you. So let's practice using these ratios. Again, if you haven't written this down yet, stop and do it, and then move on. So notice we need to find all of this. You won't have to find all of those in each of your examples, okay? It's usually just one or two in your assignment problems, okay? But for examples, this is excellent. So start with S. So we're going to find the sine of S. So from S, right, from angle S, we're going to find the opposite side. We're going to find the hypotenuse, which will be the hypotenuse for all of it, right? And then that means the other side, the side next to to S, is the adjacent, because it's the side that's not the hypotenuse but touches S. So to find the sine, and it's not sin, it's sine. Do not say sin. Sine. Okay, so the sine of S would be opposite over hypotenuse, which in this case would be 63 over 65. I didn't really have to worry about interruptions when I did these videos at home during COVID, well, except for the dog barking. Okay, so 63 divided by 65 is 0.97 rounded. It's really 0.969, blah, 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 but I rounded it to 0.97. And so that's the sine of S. Now, I'm going to go a little bit out of order, and I want to find the cosine of S next. So the cosine of S is what I'm going to find next. So again, S, opposite, I guess I didn't need to erase that, huh? Opposite, still the hypotenuse, adjacent. Okay, so what that means is the cosine of S is going to be the adjacent over the hypotenuse, which would be 16 over 65. Couple of things that you might want to at least make a mental note of. Hypotenuse is always on the bottom. On all of our ratios, hypotenuse is on the bottom. Okay? In all of our ratios, opposite is always on the top of our ratios. Adjacent is the one that kind of moves around, depending on which one you're talking about. So you would, if you ever try to put the hypotenuse number on the top, you did something wrong. So keep that in mind. And again, I did round that. So give me 2 decimals. If it makes more sense for whatever reason to give me 1 or 3, do that. I'm more worried about, do you have basically the right number there? So now I'm going to erase this, and I'm going to now do the sine of R. So again, R is over here. So the opposite is way over here. The hypotenuse is still the hypotenuse. And that means this side is our adjacent in relation to r. That is the number one thing you have to think about, is where's my angle that I'm asking about. Okay. And so the sine of r, still opposite over hypotenuse, but in this case it's 16 over 65, which we know is 0.25. Notice that the two angles, their cosine and sine are the same. Okay? Just something to think about. So if you are, it's one way to check your work, if you wanted to. Okay? Let me erase whatever that is right there. Okay. So, if we're going to do the cosine of r, our opposite, hypotenuse, adjacent are the same, because it's the same angle we're looking at. Okay, but now we're going to do a different ratio, adjacent over hypotenuse, which is going to be 16 over 65. Wait. Nope, 63. I'm sorry. I'm confusing myself. I was looking at the wrong one. Adjacent over hypotenuse would be 63 over 65, which we already know is 0.97, because again, the two angles in your right triangle that aren't the right angle should have their sine and cosine should be the same. Okay? Not anything you really are ever going to have to like know and reiterate, but it's kind of a good thing to note because it can help you figure out that you're doing things correctly, or hopefully not, but incorrectly. So, sometimes it's approached a little bit differently. So, this is kind of more like what your assignments will look like. So, we want to know what is y, what is y, what is x, what is y. So, what is x, what is y, what are those two sides, using sine and cosine. Okay, so what that means for us is that I'm going to change pen colors here. We need to think, okay, what angle do we know? Well, we know this angle. So that's the angle that we're looking at in relation to. Okay, so in relation to this angle, we've got the opposite. We've got the hypotenuse, of course, right? Opposite of the right triangle, right angle. And then we've got the other side, which is the adjacent. So, opposite, to get x, we've got opposite, right? So we've got, oops, the opposite, and then we could put opposite over adjacent for, and you have tangent, but it says to use cosine, so sine and cosine. And we've got the hypotenuse. So the hypotenuse, right? So that means we've got x over 14. So the sine of our 26-degree angle is x over 14. Now, this is where we get to use our fun numbers on, our fun buttons on our calculator. You have to have a fancy calculator, I think. Nope. They're on your phone calculator. If you turn it to like landscape, right, and you get all those buttons, the sine, cosine, etc. are there. Play with it as we do these examples, so you know, because sometimes you have to hit sine first and then the number. Sometimes you have to hit 26 and then the sine button. So play with it to make sure you get the right numbers. So on the school calculator, you would hit sine, type in 26, and you're going to get a decimal. That's that ratio that we just worked on getting. So 0.7626. You need at least 4 places there, okay, to get the most correct answer. And that equals x over 14. Now, how am I going to get that 14 off the bottom of my x? I'm going to multiply by 14, right? If you don't clear this number out of your calculator, you can just hit times, and it will take that number and put that whole long decimal in there and times it by the 14, so your answer is more correct. That's the school calculator. It doesn't quite work like that the same on phones usually. Okay, so that gives us 10.68, and that's my x. I rounded that, by the way. So to find y, we're using the same opposite adjacent hypotenuse because it's the same angle, right, that we're talking about. But in this case, y is the adjacent, and we're going to put it over the hypotenuse, and that's the cosine of 26. So I put that angle measure in there as my number, and that's what I'm going to find on my calculator. The cosine of 26 is 0.6469. And I'm going to multiply that by 14, and I'm going to get 9.06 equals y. Now, these are side lengths, okay? So that's x is that side length right there. And y is this side length, okay? Now, gotta make sure it makes sense. If you ended up with 0.2, that's probably not the side length of a triangle. If you ended up with a negative number, that is most definitely not the side length of a number. So be careful that what your answer is makes sense. Remember, your hypotenuse always has to be longer. So your opposite and your adjacent, or x and y in this case, can't be bigger than 14. Okay, so use all of those things that you know to make sure that your answer is reasonable and makes sense. Let's do one more example. Sorry, this video is so long. So 35 is the angle that we know something about, and we're going to use sine and cosine. So we're going to do sine of 35, and we're going to do cosine of 35. Okay. I'm trying to approach it differently to help as many people as possible. So opposite of the 35-degree angle is our x. Our hypotenuse is that 53, and our y is our adjacent. So the sine of 35 is going to be our opposite over our hypotenuse, which would be x over 35. The sine of 35. Somehow I just got a negative number. Hang on. The sine of 35. So the sine of 35 is 0.5736. And I forgot a very important piece, which if you're at home probably doesn't matter because you're working on your calculator on your phone. But if you are working on the school calculator or one like it, you need to make sure that your mode is in degree, not radian. The calculator defaults to radian. Our school calculators do, so you need to make sure that you do that. When you get back to school, ask me how to do that on the calculator at school. But the process is the same, it's just this number is wrong for the last example, but that's okay. The process is the same. So again, we multiply that 35 times that number we came up with. Wait, where did I get, this should be 53. Ooh, I'm dyslexic this morning. I'm just all kinds of messed up on this example, aren't I? Sorry about that. That should be 53. I'm sure you caught that already. So we multiply that, and then we get 30.4 rounding, okay? And I wrote that backwards, sorry. And that makes sense because it's got to be less than 53. So that makes, and it's positive and all that good stuff. So that makes sense. So now let's do the cosine. So the cosine of 35 is, in fact, 0.8192. Oh, whoops, I forgot to, sorry. Got so excited with my decimals. So cosine is adjacent, so that would be y over 35. So we're going to multiply that, not 35. Why am I did it again. Oh my goodness gracious. Oops. Sorry, y'all. I probably will make the same mistake in class, so there you go. Multiply, and we get 43.4. Now, I don't think I have, nope, I don't have. Yes, this will do it. Okay, so I purposely want to give you a specific example. Oh, that was this way. So we want to know how far is it that you're skiing? Okay, if you're 1,200 feet up and your angle of depression or your angle looking down is 21 degrees, how far are you going? Okay, so we are gonna figure this out. So this is the angle we know something about, right? So that means that's the angle we're looking at relation to. So opposite of that is our 1,200 feet. Okay, the opposite of our right angle is our hypotenuse, and then the other side is our adjacent, but that doesn't seem to mean anything to us because we got nothing there, right? Okay, and so then we're gonna figure out, okay, so we know something about the opposite and we know something about the hypotenuse. So I know we're gonna put the opposite over the hypotenuse, and I know that that is sine. Okay, notice nowhere in here did it tell you which one to use. Okay, so we're just using our information and kind of going backwards. We have something about opposite and hypotenuse, which is the ratio for sine. Okay, and then of course that's the angle 21. So the sine of 21 then is going to be 1,200 opposite over hypotenuse, our x. So the process is the same, but the solving for x is a little bit different. So the sine of 21 is 0.3584 rounded. Okay, now I'm going to show you the long process of what happens here. Okay, and then kind of tell you what the shortcut is. So x is on the bottom, so that means we have to multiply by our x, right? So that means we've got that whole big old long decimal times x equals 1,200. And then how do I get my x by itself? Well, I'm going to divide by our big old long decimal, right? So notice, so then x equals 1,200. I'm purposely not doing the actual math yet to show you. So notice that those two things just change place, okay? So if doing the math doesn't, it just confuses you because of the long decimal and everything, it's just know that it actually just switches place. So it's 1,200 divided by your decimal instead of times, which all of our other examples were. So 1,200 divided by, and in class I can show you how to get the long decimal in there so you don't have to worry about abbreviation. But if you, rounding, but if you do a round, your number's going to be just a few decimal places off, okay? And that's fine. When I'm, like, if this is my answer, this is the full answer, if I'm grading this, if you have 3348 point something, your answer is correct. Okay, now if you have 3350 point something, you rounded here wrong. Okay, so be careful with your rounding, but you don't have to be totally exact because there's some wiggle room here in that decimal when I do my grading. Holler if you have classes. If you have questions in class. Sorry this video was so long.